Good afternoon, everyone. Sorry I can't be there with you today. Just a reminder that tomorrow is your test for the part 2 of the polynomials unit. So I will be going through the review with you today. So let's get started. The first thing, we're going to list off the things you need to know, and I'll go through a couple examples, and then you'll have some time to work on practice questions and the assignment that is due tomorrow that you got yesterday, and that's assignment number 6. So, things that you need to know. The first thing that you need to know is you need to be able to identify the degree of a function from the equation. There are two different forms. Remember that in standard form, that's when it looks like the ax squared plus bx plus c. Or something of that form. Sometimes we also did with an x cubed in there as well. So when it's in that form, that's when it's in standard form. And to be able to tell what the degree is, remember we just look at the variable that has the highest number. So in this case, that would be the 3, so the degree would be 3. When it's in factored form, remember that's when you have all the brackets. So that could look something like this. 2x minus 1 bracket x plus 3 bracket 4x minus 5. So it might look something like that when it's in factored form. And remember, we just count up the number of exponents on the x's to get our degree. So let's look at a couple of examples. So the first example we have here is we have in standard form because it has each individual variable, no brackets. So we know that our degree comes from the variable with the highest exponent, which in this case is, when we look here, we have an x to the power of 3, an x to the power of 1, and an x to the power of 6. So 6 is our biggest, so we know our degree is 6. In our second example, it's in factored form because it has all the brackets. So we need to count up how many exponents there are on our x's. So in this x that it's out front, remember when an x doesn't have an exponent, it technically has an exponent of 1. So that would be a count of 1. This bracket here gives us a count of 2. This bracket here now, because it's squared, that gives us a count of 3 and 4. It adds 2 more to it. And then this bracket here, because it's cubed, that gives us an extra count of 3. So that we were at 4. That gives us 5, 6, and 7. So that means that our degree on this one is a degree of 7. So remember, you need to know how to figure out the degree, and we use that for a couple different things when we're working with polynomials. Okay, the second thing you need to know, and this is review from part 1 of polynomials, is your end behavior rules. Remember, we need the end behavior rules to be able to graph polynomials, and that is something that we covered in this part of the unit. So remember, you need to know your rules in the way that you need to be able to graph them. So end behaviors, remember, it's based on whatever the degree of your equation is, which is why we reviewed how to find the degree. And it's also based on the sign of the leading coefficients, whether it's positive or negative. So let's just quickly review those rules. If your degree value is odd, then remember our end behavior ends up with diagonals. So we have quadrant 3 to quadrant 1 when the leading coefficient's positive, but then the opposite, quadrant 2 and quadrant 4, when our leading coefficient is negative. And remember, in terms of numbering our quadrants, we start here with 1, and then work our way around. So this would be 2, 2. Down here we'd have 3, and here we have 4. Then if our leading coefficient is even, meaning that the degree is an even number, we know that the end behavior has to end in the same direction. So either it ends up, going from 2 to 1, or it ends down from 3 to 4, but it has to be in the same direction. So when it's positive, that means up, which is 2 to 1. If it's negative, that means down, and that's 3 to 4. So leading into the next thing was graphing polynomials. And remember, we graphed polynomials by finding some key points before we graphed. So the first thing that we found was the y-intercept. And remember, to find the y-intercept, we just plug in that x equals 0, and then we have to solve for y. So when it's in factored form, we have to simplify out the brackets to solve for y. If it's in standard form, we know it's just the last number at the end. Something else that we had to find was our x-intercepts. To find our x-intercepts, remember we plug in y is equal to 0, and then we set each bracket, once it's in factored form, equal to 0, and then we solve for x in each of those cases. And again, that's what's in factored form. If it's in standard form, then you have to factor first to be able to find the x-intercepts. The last thing that we need to be able to graph is the end behavior, and as we just talked about, that's dependent on the degree and the sign of the leading coefficient. Don't forget, there's a couple rules with your roots, aka your x-intercepts. Remember, when the bracket is squared, so that's when there's a 2 above the bracket, remember that's called a double root, and a double root bounces off the x-axis. It doesn't actually go through it. The other rule is when the bracket is cubed, so there's a little 3. Remember, that's called a triple root, and on the graph, that's what's called a point of inflection. And remember, the point of inflection means that the curve changes direction. So if it's coming up in a N shape, it then changes into a U shape instead. The curve changes the direction that it's going in, and again, that's at the x-axis. One last thing in terms of remembering for your graph is remember to label all of the different pieces for your communication marks. So remember, that's labeling your x and y axis, it's labeling the numbers on your x and y axis, it's putting the arrows at the end of your graph, and then also labeling the equation on your graph. And remember, those are all worth communication marks, and they're easy communication marks, so don't forget to do those. Let's quickly take a look at an example of something that you might have to graph. So this is the equation here. It is in factored form, so we don't have to factor it, but we need to pull out the key information for us to be able to graph it. So let's do our x-intercepts first. So remember, for our x-intercepts, we take each piece and set it equal to 0. So our first piece is this x that is out front, and we set it equal to 0, so our first x-intercept is x is equal to 0. Our second x-intercept is our second bracket here, x minus 2, set equal to 0, and when we rearrange that, we get that x is equal to a positive 2. And remember, you do have to do some rearrangement, and that's important in terms of if there's a number in front of the x. In this case, you could just read it out, because you know that when a number is negative inside a bracket, when we pull it out, it becomes positive. So you don't necessarily have to show this step. Our next root comes from our next bracket, which is x plus 1. So we know that's going to equal a negative 1 when we pull it out of the bracket. And because there's a squared around that bracket, we know that's a double root. Don't forget to label your roots as doubles and triples so that on your graph, I know that you know that that's a double root. And two, if you forget or aren't able to draw a triple root very well, then I know that you have it labeled here, so you knew it was in fact a triple root. And then our last one, 4x minus 3. Oops, there we go. And we'll have to do some rearrangement for this one. So we bring the 3 over to the other side of the equal sign first, which means that it becomes a positive 3. And then to get x all by itself, we have to get rid of that 4, so we have to divide by 4. So we get that x is equal to 3 divided by 4, or the decimal of 0.75. Remember, in this case, it's okay to have decimals in your answer because we're graphing. And it's okay to have decimals when you have to graph. And the last thing is, because there's a cubed around that bracket, we know that's a triple root, so we want to label it as a triple. So those are our x-intercepts. Let's do our y-intercept next. Remember, for our y-intercept, we set x equal to 0. So in our equation here, wherever we see an x, we're plugging in a 0. Oops. And now when we simplify that out, because we have this 0 up front, this 0 is multiplied by everything because everything's in brackets. And remember, 0 multiplied by anything is still 0. If it wasn't a 0 out front and there was just stuff in the brackets, you would have to simplify using your BEDMAS, so doing what's inside the brackets first, then applying the exponents, and then doing your multiplication afterwards to get your y-intercept value. The last thing that we need is our end behavior. So remember, for our end behavior, we need to talk about the degree. So let's count up our exponents. We have a 1 here with the x out front. We have a 1 here with this bracket. Then we have an extra 2 here, and then an extra 3 here. So that should add up to 7. Okay, and then we also need to talk about our leading coefficient. So our leading coefficient, remember, just sits in front of the brackets. If there is no number, which there isn't in front of the x either, we assume that it's a positive 1 so that we know that our leading coefficient's positive. So our degree is 7, which means that it's an odd degree because it's an odd number. And it's positive, so we know that leads us for end behavior of quadrant 3 to quadrant 1. Now that we've listed out all the key information, we can take a look at our graph here and plot it on our graph. Okay, so now that I have that set up, let's plot our points. We have a y-intercept of 0. We also have an x-intercept of 0, which is also plotted. We also have an x-intercept of positive 2 and x-intercept of negative 1 and an x-intercept of 0.75. Now those are really close together. I'm just going to adjust my graph here a little bit so that it's spaced out a little bit more just so it's easier for us to see here. So let's make that 1, 2, 3, 4, 5, 6, 7. Oops. That'd be there. Okay, let's try that again just so it's a little bit more spaced out. That's better for you guys to see. So we have 0, 0. We have positive 2. We have 0.75. And we have negative 1. So it's a little bit better there. And then we need to draw a graph. So we know that we start down here in quadrant 3 and we end up over here in quadrant 1. And we know that negative 1 is a double root, so it has to bounce off that root. And we know that positive 0.75 is a triple, so it has to do a bit of a curve here. Okay, so starting down here. Oh, and you have to excuse me, this is a little bit harder when I'm doing this on my computer. So it hits this root with bounces because it's a double. This one it just goes through regularly. For this one here though, it needs to curve kind of down in like an N shape here. And then because it's a triple root, it needs to switch directions. So it needs to come into a U shape and then go back through this one and end in our quadrant 1 up here. Now this is a little bit hard to see because it's a little bit squished. One thing that would be good for you to do, just in case you're afraid that I don't recognize that you tried to draw a triple root, is just label this as a triple on your graph. So it just goes to show that you did try to make it a triple, but sometimes it's hard to make that point of inflection obvious where it actually changes direction. And that's an example of having to graph a polynomial. Oh, one thing I just realized that we forgot is we forgot our label of our equation. That didn't work very well. There we go. And there's our label. So we get all full communication marks there. Okay, the next topic. The next topic is being able to determine the equation of a polynomial from a graph. So doing basically the opposite of what we just did. I'm going to give you a graph and you need to be able to come up with the equation. So let's look at the steps first. The first step is to read off the x-intercepts to make up our brackets in our equation. Just make sure that you are aware of your double and the triple roots. On any of those graphs, the triple roots will be very obvious, so you should be able to identify wherever there is a triple root. So make those brackets first. Then you need to choose a point. That's usually the y-intercept, but we did see one example where we had to choose a different point other than the y-intercept. But usually the y-intercept, as long as it's a nice point that's easy to read off, meaning there's not a decimal where you have to guess approximately where it is. Then we plug it into the equation for the x's and the y values, and then we solve for our leading coefficient of a. Once we know what that equation is, or sorry, what we know what a is, then you need to state your final equation. So you're going back with the brackets with all the x-intercepts, and your only variables should be the y and the x. Because remember, for it to be considered an equation, it has to have your two variables of y and x. So let's go through an example. So we have this graph here. And we have to come up with an equation for it. So we start off with y equals a, where a is our leading coefficient and we don't know what it is yet. Then let's take a look at our x-intercepts. Looking down here, I know I have an x-intercept at the bottom here where it hits at 2. And remember, when you put something inside a bracket, it always changes the sign. So because that's a positive 2, that means this is going to be x minus 2. And because it bounces at that point, we know that that is a double root, so we have to throw a squared around that bracket. And then let's take a look at our second x-intercept. It hits here at -4. So when we put that inside of our bracket, that becomes an x plus 4. And then looking at this root here, I'm just going to erase the circle here so it's a little bit easier to see. Looking at this root, we can clearly see that it comes down in a U shape at 4, but then directly changes into that N shape. So this is a triple root. So because that's a triple root on our brackets here, we have to throw a 3. Now that we have our brackets, there are no other x-intercepts, we need to find our point that we're going to use. So let's take a look at our x-intercept, or our y-intercept, sorry, to see if it's a nice number. And in fact it is. It is the point 0, 64. So now that we know that that's our nice point of 0.64, we want to plug that into our equation for x and y. So in our equation for y, we plug in the 64, and for x, we plug in the 0. Now that we've done that, we need to simplify this out so that we can solve for a. So here we have 0 minus 2, which gives us a -2, and then we square it, and -2 squared gives us a 4. Oops. And in this bracket here, we have 0 plus 4, which just gives us a 4, and 4 cubed gives us a 64. Then we need to multiply those two numbers. So 4 multiplied by 64 gives us 256. And then our last step to get a all by itself is we have to divide out this 256 so that a is all by itself. Now when there's a fraction like this, you should always try and reduce it. Please don't put it into decimals unless it's a very nice decimal, meaning that it only has one decimal place, 1 or 2 decimal places. So in this case, let's reduce our fraction. If we divide both top and bottom by 50 or by 64, we get the fraction of 1 over 4. So we know that our leading coefficient is a positive 1 over 4. Now that we've solved for a, don't forget your final statement. That's worth your 1 mark, your 1 communication mark. It's stating your final equation. So we now have 1/4 in the a position, and the rest is the same from our brackets here. So that this here is our final answer. Okay, so our next topic that we covered in this unit was factoring polynomials. So, a couple things that we need to know and use when we are factoring polynomials is the remainder theorem. Remember, the remainder theorem tells us when p at x, which is just our function, is divided by some binomial, something x minus k, where k is just one of our numbers, we know that the result is p when we plug in k. So when we take our function and plug in the number in the binomial, we'll get whatever the remainder is. The other thing that we use is our factor theorem. Remember, the factor theorem is that when we do this, when we take that number k and plug it into our function, we get the result that it's equal to 0. If the remainder is equal to 0, we know that that x minus k, that equation is a factor of the p at x, and we can do our then division to divide it out. The other little piece with this, as with both of these theorems, is we also have the case when there's that number sitting in front of the x. And the same rules apply. The only difference is that we have to set it equal to 0 and rearrange to know what x is equal to. So when we do that, we get k divided by j. And that's what we plug into our function to figure out what the remainder is and to figure out if it's a factor or not. So just quick review. Remember, it's a factor if the remainder is equal to 0, and you figure out what the remainder is by taking this number and plugging it into the function. There was a couple different things that we looked at when we were factoring. The first one is make sure you always check for a common factor. That's the first thing you should always do when the question asks you to factor or it requires you to factor, is check for that common factor first. Because it can simplify your life a lot if you recognize when a common factor appears and pull it out of your equation. The next thing that you want to do is you want to see if you can factor by grouping. There's a couple of conditions with factoring by grouping. The first one is that you must have 4 terms to be able to factor by grouping, because remember that's when you break it in half and you find a common factor of the first 2 and a common factor of the second 2. The second restriction is factoring by grouping is when you're finding those common factors, the 2 brackets that are left when you do that common factor from each half has to be the same. If those 2 brackets don't work out to be the same, you can't do factor by grouping. If you check for factor by grouping though and find the situations where that works, it saves you a lot of time because it's faster than using our factor theorem and having to use our longer synthetic division. So if common factoring and by grouping doesn't work, or you're still stuck with stuff that you have to factor, then we have to factor using our factor theorem and our longer synthetic division. Remember, that's where we have to do a little bit of guess and check of choosing numbers, plugging them into the function to see if our remainder is equal to 0. If we get a remainder equal to 0, then we do our division with that number, and usually we use synthetic division because that's what works best in most cases. The last thing is usually once you've used the factor theorem once, you have to finish off factoring because you'll still have a bracket that's left over that has an x squared in it, and we just use the appropriate strategy to help us out with that. The first thing is we can use inspection, and we still use that M&A. We have to multiply to the last number, but add to the middle number. And we do that when there is no value in front of the x squared. So that when there's no number sitting in front of that x squared, we can use inspection. The second one is decomposition, or for those who liked it, you can use guess and check. Again, for decomposition, you still have to use the multiply and the add method. And this is the case as you have to use decomposition or guess and check when there is a value in front of the x squared. So whenever there is that number sitting in front of the x squared, you have to use decomposition. Another case that you can look for to help you solve things out is a difference of squares. Remember, difference of squares appears when we only have 2 terms in our equation and there's a minus in between them. The last thing is if we can't factor it using any 3 of those strategies and none of them work and we can't seem to find numbers that will work to multiply or to add, then we use our quadratic formula because otherwise we can't factor. Remember, the quadratic formula will be given to you if you need it. So let's look at some examples of practicing factoring. So our first one here, we're asked to factor this equation here. We have 4 terms. Let's first check to see if there is any common factor that we can pull out of these terms. So looking at each of these terms, I see that there is a variable x in every single one of these terms. Doesn't look like there's any number I can pull out because this one's a 1 and there's nothing we can pull out of a 1. But we do have an x that we can pull out. So let's start off with that. So we're going to pull out an x out front, and then we just take that x out of each of our terms. So instead of 4x to the power 4, it's now going to be 4x cubed. And then we're going to have minus 12x now squared. And then minus an x, and then plus a 3. So each term just loses one of their x's. Now that we've pulled out that common factor, which simplified it out a little bit, let's take a look at our terms here. Again, we have 4 terms in this, so let's check to see if we can do factoring by grouping before we result to using the factor theorem and our synthetic division. So remember, for our factoring by grouping, we split our equation in half. Oh, that's quite big. Let's not use that. So out of our first 2 terms here, we want to look for a common factor that we can pull out of our first 2 terms. So I can see that we can divide both of these numbers by 4, and they both have x squareds in them, because this one has 3 x's and this one has 2 x's, so we can pull out 2 of those x's. We can pull out an x squared as well. Now that we've pulled that out, remember we have to then take these 2 terms and divide it by what we're pulling out. So 4 divided by 4 gives us a 1, and x cubed divided by x squared just leaves us with a single x. And remember, you can think about that as x cubed has 3 x's in it, and x squared has 2 x's in it, so we're taking 2 out of the 3, so we're only left with 1 x. For our second term here, negative 12 divided by 4 gives us negative 3. And then because this is x squared and we're taking out an x squared, we don't have any x's left, so it's just x minus 3. Now looking at our second 2 numbers here, I don't see any number that we can divide out of both of them. But remember, we're trying to get the bracket to be the same. So if we look here, if we take out a negative 1, which is really the only thing we can divide out of both terms, a negative x divided by negative 1, the 2 negatives cancel, so we're just left with a positive x. And positive 3 divided by negative 1, positive and a negative, remember, make a negative, so we get x minus 3. Now this is really good for us because now we see that our 2 brackets that were left over when we did those common factors were exactly the same. So that means that we're good to go to do our factoring by grouping. If those 2 brackets weren't the same, we wouldn't be able to continue with factoring by grouping, and we'd have to use our factor theorem in synthetic division. So let's continue. Now that those 2 brackets are the same, they make our first bracket here in our final answer. And then remember, everything in front of those 2 brackets make up our second bracket. So our second bracket then is 4x minus 1. Or sorry, 4x squared. 4x squared minus 1. Now that we've done that, we see that we have everything broken up here in brackets. But looking at this bracket here, we still have an x squared. And remember, you're not done factoring until we no longer have any exponents on our x's. So we have to see if we can keep going in terms of being able to factor this. So looking at this, we only have 2 terms here, and there is a minus in between. So we look back at our strategies. Remember, that's our difference of squares. So we can use difference of squares on this one because it meets our conditions of 2 terms with a minus in between. So all of our other brackets stay there. But this one, remember, to do a difference of squares, we square root the first term. So let's just do that off to the side. The square root of 4x squared gives us a 2x. And the square root of 1 just gives us a 1. So what we do in terms of our answer, we know that our answer is going to have two sets of brackets. In our two sets of brackets, the square root of the first term comes first, so we have 2x to start off each of our brackets here. And then the value of the square root of the second term makes up the second piece of our brackets. And then remember, one bracket gets a plus and one bracket gets a minus. Now looking at this answer here, we don't have any exponents left on our x's, so it's fully factored and we're done. Our next example here talks about applications. Oh, sorry, I missed an example. Let's go back. Right, there was another second factoring example here for us to look at. So with this one, again, we want to look to see if there's any common factors we can take out. But quickly looking, we can see that there are no common factors. Nothing can divide out in terms of numbers, and we don't have a variable in every single term anymore, so we don't have any common factors. Then we want to see if we can do factor by grouping. We do have 4 terms, so that's a good start. But looking at our first 2 terms, all we can take out is some x's, and the number that we have left here is a 4. In our second 2 terms, there's nothing we can take out, and the number that's left is a 6. So those 2 brackets, if we tried to do factoring by grouping, aren't going to equal the same, so we can't do factoring by grouping. So because those 2 have been eliminated, we know that we have to use factor theorem and synthetic division. In this case, remember, to get started, we always look at, whoops, there we go. We always do our guess and check. So what can we plug in that will give us a remainder of 0? So we can try plugging in a value of 1 into our equation. So we would have 1 cubed minus 4 times 1 squared plus 1 and plus 6. So 1 cubed is 1 minus 4 times 1 squared would be a -3, plus 1 gives us -2, and then plus 6 gives us a +4. So this doesn't equal 0, so we know that this is not a factor. So we can't divide by +1. Typically our next one to try would be p at -1, so plugging in -1 into our equation. So -1 cubed gives us a -1. Here we have -4, but -1 squared is a +1, so then we're still minusing 4. And then we have -1 plus 6, which would give us a +5. So -1 minus 4 plus 5 gives us 0. So that means that this is a factor. So that's what we're going to divide by. So we know that -1 is a factor, so we throw -1 out front in terms of our synthetic division. Remember, with synthetic division, we have this here. We have our little division symbol. And then what goes inside our division symbol, remember, is the coefficients of our equation here. So remember, our coefficients of our equations are the numbers that sit in front of our variables. So the first one here is a +1. And then here is a -4. And then we have a +1. and a positive 6. Then in terms of our synthetic division, remember we always carry down the first number. So we get a 1 down at the bottom. And then we take that number and multiply it by the number out front. So -1 multiplied by 1 gives us a -1. And then we add up our column here. So -4 plus -1 gives us a -5. And then we repeat that process. So -5 multiplied by -1 gives us a +5. Add up our column. 1 plus 5 gives us 6. 6 multiplied by -1 gives us -6. Add up our column. 6 plus -6 gives us 0. Remember that the last number here in synthetic division is always our remainder. So we have a 0 remainder, which we have to have because it was a factor. And now our answer, remember, comes from the bottom underneath this division symbol here. So let's write out our answer. Remember, the first part comes from what we divided by. X is equal to -1. To put that in a bracket, remember the sign changes. So that's x plus 1 inside the bracket. And then in terms of our answer, remember to add the variables back in, we always start with one less than the highest variable that we had in our question. So we started with an x cubed. So that means here we're starting with an x squared. So we have 1x squared minus 5x, and then plus 6. Now that we have that factored, we have to look at this bracket here because there is an x squared in that bracket. To factor this bracket, there is no number in front of the x squared, so we can try doing inspection with m and a. So remember, our multiply number always comes from the last number multiplied by the first number. So we have 6 multiplied by 1, which is 6. And our add value always comes from the middle number, which in this case is -5. So we need two numbers that multiply to 6 but add to -5. Those two numbers happen to be -2 and -3. Now that we have those two numbers, because it's inspection, meaning that there is no number in front of this x squared here, we can throw those numbers directly into the brackets. So we get x minus 2 and x minus 3 in our brackets. And now looking at each of our brackets here, none of them are squared. So we know that we're done factoring. We don't have to go any further. And that's an example of factoring having to use our factor theorem and our synthetic division. The last thing that we covered, and we just covered that the past couple of days this week, is the applications of using polynomials. So the key things that you need to know with the applications of polynomials is you need to be able to develop an expression for a prism by using expanding techniques. So that's when the dimensions of some sort of prism, we looked at rectangular prisms and we looked at circles and we looked at triangles, is you need to be able to come up with an expression with the side lengths will have some sort of variable x, and our expanding techniques included foiling and our distributive property. We also determined the maximum value that a prism, the maximum volume that a prism could have by using technology and determining the appropriate logical domain, meaning that we had to cancel out any of the areas of our graph that included the x variable to be negative or the y variable to be negative, because we can't have negative distance or negative time. So we have to rule out those different sections and then come up with what are the two numbers that the x can be in between. And that was using technology of using Desmos. And remember, there will be a question like this on your test. You will get an iPad that allows you to use Desmos and only Desmos to do this type of question. So make sure that you're familiar of how to type equations into Desmos for this type of question. The last thing is to be able to explain the use of an item based on the shape of the graph. So if there is the shape of a graph, you should be able to just talk about what's happening in that graph logically with the word problem. And there's a good example of that in that one worksheet from Tuesday. So if you want examples, I'm not going to go through any right now because we saw a lot of examples of this week. You can see the lessons and the homework. So that homework was that textbook work and the worksheet from Monday and Tuesday. So make sure you take a look at those if you have any practice problems you want to go over. That is it in terms of content for this upcoming test tomorrow. A couple other things for you to take a look at is I do have the format here of your test. So under the knowledge section, you will have some multiple choice questions. You will have 6 of those worth 6 marks. There is also some short answer questions. There will be 2 short answer questions, and that gives you a total of 5 marks. In your application thinking problem solving section, we have our long answer questions, and there are 4 long answer questions, and that gives you a total of 19 marks. Remember, for communication, that's evaluated throughout your test based on the legibility of your work, that you have clear answers, that you've shown your steps, and then it's clear how you got to your answer, including therefore statements for any word problems, and also proper labeling, especially on graphs. And you have 6 communication marks on this test. If you're looking for some review and some extra practice problems for you to practice your skills to be ready for the test tomorrow, in your textbook on page 156, there are a number of good examples for you to go over. And then remember, great things for you to review and look over are the notes and the homework questions. Remember, I often take examples that are very similar to ones that we have seen in your notes and in your homework on the test, so make sure you look over those as well. Also, a reminder, if you have any questions before the test, I'm in this room at lunch, then you come tomorrow and ask me questions. For the rest of the class, you have time to work on studying or practice questions or work on the assignment that you got that is due tomorrow. So don't forget to get that done so you don't get any late marks. Have a great day, guys. I'll see you tomorrow.